Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths B. We have started a discussion with the chapter circles. Till now, what did we discuss? We discussed only the equation of circle, tangent, chord of contact, normal, polar, right, and also the pole and the equations of tangents, angle between two tangents, right. These are the different parameters. We also learned what is conjugate points. Yes, today we are going to start with two different circles, what happened when they interact with each other. Okay, what is the relationship between the tangents of the two circles, right? Do we have any common tangents, or how many kinds of tangents do we have if I have two circles? Yes, shall we discuss? See here. There are different kinds, there are different variations when we consider about two circles. The first condition is two circles do not touch at all. Okay, one circle is here, one more circle is here. So, how the condition is here? They are not at all touching each other. Then what is the condition? If you observe the distance between from the center to the center, let us say the distance from C1 to C2. Okay, C1 is a point, C2 is a point, and the distance between these 2 points is always greater than the radius ka sum. Okay, the sum of the radii R1 plus R2. From here it is R1 and here it is R2, and the distance between C1 and C2 is very high than the sum of R1 and R2. Clear? It clearly tells that both the circles are not at all touching each other. Okay, good. Next, second condition, both the circles are touching at only one point. Yes, clear, which means these circles are touching externally, right, at a point, let us say some point. Then what is the condition here? The distance between two centers is equal to sum of the two radii, isn't it? The distance between two centers, that is C1, C2 is always equal to R1 plus R2. Clear? Do we have a point of intersection? Yes. So, you have to remember is circles touching externally and point of contact is internally. Is it clear? You do understand? In which ratio do they divide? That is, if I want to find this point, if you remember the section formula, we can find this point, let us say P, that it is dividing C1, C2 in the ratio R1 is to R2. Clear? You do understand? Once again see here, this is very important condition, that is why I am taking time here. When the two circles touch each other at one and only one point, then the condition should satisfy C1, C2 is equal to R1 plus R2. Then we can tell that both the circles are touching each other externally and the point of contact is found out in the ratio R1 is to R2 internally. Okay. And the next, when the two circles are touching like this at two different points, then what does this mean? The C1, C2 ka distance is less than sum of these two. Yes, clear? It is almost equal and this is more and this is very much less than R1 and R2. Clear? And we have 2 points and we can have a common chord here. Yes, good. And the next one more condition, these two circles are also touching only at one point, but here it is touching externally and here we can tell it as they are touching internally because one circle is completely inside one more circle. So, the condition is C1 minus C2 is equal to R1 minus R2. Okay, that is the difference between two circles, isn't it? So, then only it can touch one other circle. Why did I put mod? Because anything can be more, either R1 or R2. Clear? So, we can tell that circles are touching internally, okay, and the point of intersection is externally. that is in the ratio R1 is to R2, you can find it. Next, here both the circles are inside the circle. So, we need not write this kind of relation for this also, there is no relation between that. So, both the circles are one inside the other, they are not at all touching. Clear? Did you understand? Fine. These are the different conditions of two different circles either touching or not touching each other. Did you understand? Fine. With this introduction, let us have a discussion about pair of tangents. Okay. Till now, what do we know? A pair of tangents are a tangents drawn from a particular point onto the circle. Yes. And what if we have two circles? How many common tangents do we have? Tell me. Before that, for a circle, how many tangents can we have? We can have infinite number of circles, that thing you know. How many tangents can we draw from a single point? Only two tangents. Yes. Similarly, what if we have two circles? How many common tangents we can draw? That is, as we discussed in our last class, we can draw 4 common tangents for this kind of circles. Okay. If you observe, if two circles are not at all touching each other, we can draw 4 common tangents. Okay. And whatever the point of intersection between these common tangents is called as center of similitude. Okay. Is it clear? Here we can, since it is internally, we can call it as internal center of similitude. Similarly, we can have external center of similitude also. Clear? So, we have 4 different common tangents. Okay. In order to differentiate it separately, we call these 2 tangents as direct common tangents. These names are very important, DCT. Clear? And since these are in the crossway, these are called as transverse common tangent. Let me write it here. Transverse common tangent. This is TCT. Clear? This tangent and this tangent. Is it clear? Similarly, how many tangents can we have here? 1, 2 and here 3. Clear? And here only 2 tangents. Yes. What about here? Here we can have only 1 tangent. Clear? And here we can't get any number of tangents. Is it clear? Did you understand? What is that we have to remember is, we have to remember these conditions. Is it clear? Shall we start doing problems on this kind of questions? Fine, let us do. Look at the questions here. He is asking us to find, discuss relative positions of these 2 circles, which means we have to find C1, C2, R1, R2. What is C1, R1? That is the center and the radius of the first circle. C2, R2 is the center and radius of the second circle. Then next we have to find the relationship between the distance between C1 and C2 and the relation, okay, with respect to radii. So, let us find C1. What is C1? 2, 3. What is radius? Under root 4 plus 9 plus 12, which is 4 plus 9 is 13, which is 5. This is R1 and that is C1. Okay. Hope everyone know how to find the center. Yes, that is 2gx plus 2fy plus c. 2g is minus 4, so g is minus 2. Okay. And the center formula is minus g, so it will be plus 2. Similarly, minus f, and the formula for radius is g square plus f square minus c. Clear? Did you understand? Similarly, C2 is minus 3 comma minus 9 and the radius is under root 9 plus 81 minus 26. How much is it? 9 plus, first of all 81 plus 9 is 90. 90 minus 26 is 64. 64 ka root is 8. Clear? And the next step, we have C1, C2 is common in all the conditions. So, let us find the distance between these 2 points. So, C1, C2 distance is under root x2 minus x1 whole square that is 2 plus 3 whole square plus 3 plus 9 whole square. 2 plus 3 is 5 square, 3 plus 9 is 20, 3 plus 9 is 12 square. How much is it? 25 plus 144, that is root 169, which is 13. Now just add 8 plus 5, is it not 13? Yes, they are 13. Therefore, C1 C2 distance is R1 plus R2. What is the condition? It clearly tells that both the circles are touching each other. Yes, both the circles are touching each other. C1 C2 is equal to R1 plus R2. Clear? So, therefore, circles touch each other internally or externally? Externally. Is it clear? Do you understand? There is a basic of the problem which we are going to do in the further questions. Okay? See here. And the next question. Find the number of common tangents to these two circles. What is the thing we have to do? Again the same condition. We have to find C1, C2 and the next R1 and R2. Then find the condition between them. Then we will decide how many tangents it can form. Okay. Similarly, C1 is minus 3 comma minus 3. R1 is under root 9 plus 9 minus 14. Okay. 9 plus 9 is 18. 18 minus 14 is 4. That is R1 is 2. Yes. Similarly, C2 is 1 comma 2. 1 and here it is 2. Therefore, R2 is under root 1 plus 4 plus 4. How much is this? This is 9. R2 is 3. And the next step we have to find the distance between C1 and C2. That is under root 1 plus 3 whole square, 2 plus 3 whole square. This is 4 square plus 5 square, which is 4 square is 16 and the 5 square is 25. Yes. So, 16 plus 25 is 25, 35 root 41, right. So, root 41, it lies between which two roots? That is, it lies between 6 and 7, yes or no. So, 3 plus 2 is 5. Okay. Now, tell me, let us take it as some 6.5 as root 41. So, just tell me C1 C2 is more than R1 plus R2. C1 C2 is more than R1 plus R2. Then what is the condition? So, we can have this kind of circle. So, we can have 4 common tangents. Clear? So, therefore, circles do not touch each other. So, we can write that it can form 4 common tangents. So, it can have 4 common tangents. Okay, that is 2 direct and 2 transverse common tangents. Clear? Shall we move on to the next problem? Let's do. Look at the questions here. He is asking us to find internal center of similitude of these two circles and here external center of similitude of these two circles. Okay. See here, remember the condition we are going to find is, we will have two circles, we will first find the condition whether C1 C2 is greater than R1 plus R2 or less than R1 R2, like that. Yes, from that we will tell that the center formed by the common tangents is internal similitude or external center of similitude. So, instead of finding that, they are directly asking us to find internal center. So, the condition is the point is touching internally, that is whatever the point of contact is, that is dividing internally. What is the formula for internal section? That is mx2 plus nx1 by m plus 1. You know that kind of thing is very popular. Yes. For example, if I have two circles, these two circles are touching externally. So, I can tell that the point which is formed, the point of contact, it can be internal center for similitude. So, this is C1, this is C2, this is R1, this is R2. Okay. Now see here, what is C1 here? C is minus 3 comma 1, right. What is R1? Under root 9 plus 1 minus 1, which is 3. Yes, similarly we can find C2, that is 1 comma 3. R2 is under root 1 plus 9 minus 9, which is 1. Okay. Then we can tell that the point P we get, that is point P is internal center of similitude dividing C1 C2 का line in ratio, what is it? R1 is to R2, that is 3 is to 1. Clear? What is C1? This is C1 and this is C2. So, we can find the point as mx2 plus nx1 by m plus n comma my2 plus ny1 by m plus n. What is this m and n? This is the ratio m and n. What are the points here? This is x1 y1 and this is x2 y2. Let us substitute it. So, that is nothing but m is 3 into 1 plus 1 into minus 3 by 3 plus 1 comma 3 into 3 plus 1 into 1 by 3 plus 1, that is equal to 3 minus 3 by 4 comma 9 plus 1 by 4. Therefore, the answer is 0 comma 5 by 2. Yes, here 2 5, I mean 2 2s are 2 5s are 3 3 will get cancelled. Clear? Did you understand? The condition we have to remember here is, since it is internal, we will use internal formula of section formula. Here he is asking us to find external center. What is the difference between internal center and external center? The only difference is here will have plus and there will have negative sign. So, let us find out first centers. Center of this is 1 comma 3, radius of this is under root 1 plus 9 minus 9, which is 1. Second center is obviously origin. Second radius is, it is in the form of x square plus y square equal to r square, that is 2. Yes. So, we can find the external center of similitude is dividing C1 C2 in the ratio 1 is to 2, okay, that is R1 is to R2. So, we can write the point as mx2 minus nx1 by m minus n, and the next my2 minus ny1 by m minus n. This is m is to 1 and this is x1 y1 and this is x2 y2. Clear? So, we can write it as 1 into 0 minus 2 into 1 divided by 1 minus 2 comma m into 0 minus n into 3 by 1 minus 2. Therefore, this is minus 2 by minus 1 and here it is minus 6 by minus 1. Therefore, the point is 2 comma 6. Clear? Did you understand? What are the conditions we learned? We learned that when two circles are far away, then the condition is C1 C2 is greater than R1 plus R2. When they are touching each other, condition is C1 C2 equal to R1 plus R2. If they are going inside, one more condition. If the circle goes completely inside and touches only one point, that is one condition. If the circle completely goes inside without touching the external circle, that is one more condition. Based on that, we learned how many number of common tangents it can form, and we learned how to find condition and the common tangents and this internal external centers of similitude. Clear? Did you understand? Fine. These are the basic problems for today. Let us meet in the next session with the more problems of circles.